We know that the GCD of two numbers a and b, where a and b not both 0, is the largest common divisor of a and b, and it happens to be the largest positive common divisor. Now, since this is the largest divisor that we can take out from a and b commonly, we can probably guess that if we remove d from both a and b, in the sense that suppose we consider the integer a by d and b by d, since we have removed the largest common divisor from both this a and b, we can expect probably that a by d and b by d will not be having any other common divisor, of course, other than 1. We are going to see that this is in fact true. So this is what we want to show. Given a, b, two integers, not both 0, d the GCD of a and b, we want to show that if we take out the GCD d from both a and b, that is, we consider a by d and b by d, then the GCD of these two numbers is equal to 1. That means taking out GCD leaves two new numbers with no common divisor other than 1. So we have to find out the GCD of a by d and b by d, and we have to verify that that's going to be equal to 1. To start with, let us assume that d dash is the GCD of a by d and b by d. So we have to show that this d dash is nothing but it's equal to 1. Since d dash is the GCD of a by d and b by d, d dash is a common divisor. D dash divides a by d and d dash divides b by d. This is known to us, and d dash is the largest satisfying this property. Now d dash divides a by d. Symbolically we can write it like this. There exists L1, an integer, such that a by d, since d dash divides a by d is a multiple of d dash. L1 d dash. There exists L2, an integer, such that b by d equal to L2 into d dash. We have to now make use of the fact that d is the GCD of a and b. But here we don't see any d here. Instead, we are seeing a by d and b by d. If we want to use d and its connection with a and b, we need to bring a and b to the left side and d probably to the right side. So if we rearrange these two equations, that is a by d equal to L1 d dash and b by d equal to L2 d dash, we get a equal to L1 d dash d and b equal to L2 d dash d. Now, see here we have d dash d, d dash d, that's a common divisor of a and b. Therefore, d dash d divides a and d dash d divides b. We know that d is the GCD of a and b, and d dash d is also a positive divisor of a and b. Why it's positive divisor? D dash is positive, d is positive, so d dash into d is also positive. So it's a common divisor of a and b. Any common divisor of a and b must be less than or equal to its GCD. Therefore, d dash d less than or equal to GCD of AB, which is equal to d. But not that d dash d. So here we have d dash d less than or equal to d. But d dash d is a positive integer, d is also a positive integer. So another rearrangement will give us that d dash d minus, or we'll take it the other way. We'll take it as d minus d dash d greater than or equal to 0, or d into 1 minus d dash greater than or equal to 0. Now d is a natural number. This is positive. Therefore, this must be greater than or equal to 0, because if it's negative, positive into negative will give us something negative, but here the product is greater than or equal to 0. Therefore, 1 minus d dash greater than or equal to 0, or 1 greater than or equal to d dash, or d dash less than or equal to 1. But d dash is a natural number. D dash is a natural number, is a positive integer. Therefore, D dash less than or equal to 1 means that there is only one possibility. That possibility is that D dash must be equal to 1. Therefore, D dash must be equal to 1. But what is D dash? D dash is the GCD of A by D and B by D, and we get this to be equal to what? This is what we claimed initially. So the GCD of two numbers, after taking the GCD from the previous numbers, it's going to be equal to 1. That means taking out the greatest common divisor gives us two new numbers with no common divisor other than just 1. In this problem, we have taken GCD out of two numbers, and so what happens to the GCD of the remaining two numbers? Now, instead of dividing given two numbers with some number, we can think about multiplying the given two numbers with some other number and think what happens to the GCD of the new numbers. That means, suppose that we have A and B given, and GCD of A and B is known to be equal to some D. We want to think what happens to the GCD of MA and MB, where M is some other positive integer. That means under multiplication, what happens to the GCD of two numbers? Since we need some more extra tools to prove that a GCD of MA and MB is going to be equal to M times the previous GCD, that is D, we will go to prove something else. We will go to some other interesting problem. Next problem we want to discuss is the following. If GCD of A and B is given to be equal to D, what we can say about GCD of A and B plus A? That means we modify the second number by adding the first number to the second number. So this is what we want to see. What happens to A and B plus A? What is the GCD of these two numbers? So D is given to be the GCD of AB. We are proceeding like this. So we know that D divides A and D divides B. Therefore, D divides A and D divides B. This is not. So D divides A and D divides A and D divides B together implies that we know that D divides any linear combination of A and B. Therefore, D divides A plus B also, which is B plus A. So D is a common divisor of of A and B plus A. That is not to us now. Now, we want to see the GCD of A and B plus A. So, suppose D dash is the GCD of A and B plus A. So, D is the common divisor and D dash is the largest common divisor. Therefore, D must be less than or equal to D dash, since D dash is the GCD. Now, D dash divides A and D dash divides B plus A implies together that D dash divides the linear combination, and we consider the linear combination, this is D dash. Consider the linear combination B plus A minus A, or B plus A minus, okay. This implies that D dash divides B also. Therefore, D dash is the common divisor of A and B. But what is the GCD of A and B? That is D. Therefore, D dash must be less than or equal to GCD of A and B, which is D. So D dash less than or equal to D, and here we have D less than or equal to D dash, and these two together imply that D equal to D dash. Or in other words, if you add the first number to the second number, the GCD of the numbers will remain the same. So in the same way, we can show that GCD of this is also true. A, B is equal to A, B minus A instead of B plus A. And one more thing is A plus B, B, all these things we can verify. We can verify all these things. Now, see, we added one number to the other and left one of the numbers the same. What about the question now is, what is the GCD of what is A plus B, A minus B, if AB is equal to D. So can we relate in the same way the GCD of A plus B and A minus B with the GCD of D. And if you want to say the answer that the GCD of the new numbers A plus B and A minus B is also going to be equal to D, that is not true because we can look at this example, this simple example: A equal to 1, B equal to 1, then GCD of AB equal to 1, GCD of A minus B, uh, what is that? What are the two numbers we have taken? A plus B and A minus B. A plus B, A minus B. This is equal to A plus B is 2, A minus B is 0. This is equal to 2. Therefore, these two are not the same. Therefore, so we cannot say that GCD of A plus B, A minus B is going to be equal to GCD of AB. But now there is another question. So we have seen that these two GCDs are not the same, but can we connect them in some other way? That means, can we say that the GCD is going to be related to GCD of A plus B, A minus B is going to be related to GCD of AB, like it's a multiple, it's a factor. So can we say something else? That's a question remaining, and that I'm leaving it as an exercise.